Students, let us start with the next part of Fresnel's biprism experiment, and here is the first question of this module, that in a biprism experiment, the slit is illuminated with the width of wavelength 5000 angstrom unit. How many fringes will pass through the point on the screen if the path difference is altered by 0.005 centimeter? So we just need to find out the number of fringes and the thickness going around here. So the given data are clear. So options are like A is 50, B is 100, C is 150, D is 200. Let us begin with the solution. Now the solution would start from n equals to nothing but the formula of path difference upon lambda. As we know, path difference is n lambda. We can say n is equal to path difference upon lambda. Now we also know that path difference here is 0.05 centimeter, so it would be converted into meter by multiplying 10 to the power minus 2. The whole upon wavelength is converted to meters as 5 into 10 to the power minus 7. On solving this, we get n is 100. So students, it is pretty clear that the number of fringes that would pass through this point on the screen are nothing but 100. So here is the option B. Option B is going to be the answer for this question. Let us move to the next one. The next question is like, fringes are produced with monochromatic light of wavelength 5500 angstrom unit, and a thin glass plate of refractive index 1.5 is then placed normally in one of the paths of the interfering beams, and the central bright fringe is found to be shifted to the position previously occupied by the third bright band from the center, you see. So the thickness of the glass plate, you just need to determine how thick is the glass plate right now. If you observe clearly, then the new fringe is replacing the third bright band with respect to the center. So this is related to shifting type numerically. It's coincidence, it's like bands are coinciding. So you just need to keep those concepts in your mind before solving this question. Let us see the options. What are they? So the option A is 33 into 10 to the power minus 4 meter. Option B is 16.5 into 10 to the power minus 7 meter. C is like 33 into 10 to the power minus 7 meter, and D is like 33 into 10 to the power minus 5 meter. So I would begin my solution, and it would be like number of fringes shifted, n is nothing but equals to n minus 1 the whole upon lambda times of t. Now students, what are the things which is given here? Let us substitute them. So we have number of fringes shifted, that is n is 3, refractive index small n is 1.5, then lambda is converted from 5500 angstrom unit into meters as 5.5 into 10 to the power minus 7. The only term left is thickness small t. Now 3 is equal to all these things. Let us solve this. Let us solve the bracket first. 1.5 minus 1, what is it exactly? It's 0.5, right? So the only change would be 0.5 in the numerator. And there is 0.5 in the numerator, 5.5 in the denominator, so I would be just cancelling it. It would be like 5 ones and 5 11s. So it would be like going, T is 33 into 10 to the power minus 7 meters, students. The option C is the answer for this particular question. So this is how you should solve when number of bands are shifting with respect to center. So that's it for this particular module. Thank you.